So now that we have a character working, our character can move around, they can look around with the mouse, or they can look around the controller, either or. Let's actually get in a character in here, like an actual character mesh. Let's get the character mesh animated, to make our game look more professional rather than just using this like little debug cube man that I'd made, so we can test the rotations and see if it's working. To start, let us head on over to Mixamo. And the first thing I'm going to do in Mixamo is go to our characters, and I'm just going to select the character I want. If you want to bring in your own character, feel free. It is just much easier to use these Mixamo characters because they're guaranteed to work with most of their animations. So I'm going to do that. I'm going to select the character Remy, hit use this character. And if you have an animation playing, we want to make sure to do T-pose. Select T-pose. There you go. That's one we want. Make sure we hit download. We want to download this with the skin as a binary FBX, and then we just hit download, and that is going to download it. I've already downloaded the character plus all the animations we need, so I'm not going to hit the button again, but just remember, download with skin. Next, let's just download the animations while we're here, so that we don't have to come back to Mixamo. We need 5 different animations. We need one for running forwards, one for running backwards, one for running left, and one for running right, as well as an idle animation. When they're not running, we don't want them to be in T-pose. That's weird. So let's get an idle for that as well. If I search run, the animations I'm going to use are the ones of this soldier holding what looks to be a rifle. You can see there's run forward, run left, run right, and somewhere there is, run backward. So I know that this animation has all the directions, so I'm going to be using that. If you do find other ones that have all of it, feel free to use that. Or, to follow along, use the ones that have this running animation, because we know it has left, right, back, and forward. With the running animations, notice how the character moves. We don't want that, so make sure you check in place so the character is just moving in place. Our code is the thing that's going to be moving the character, not the animations. So we don't want the animations to affect our character's movement in any way. It's just going to be playing on top of, where our character is actually moving. So make sure in place is there. You can mess with the overdrive or arm space. Don't mess with the trim, because as you can see, this animation is looping perfectly. If I was to mess with the trim, the animation just won't loop perfectly anymore. So they've set up all these animations so they loop properly, so there's no point messing with the trim. So let's download again, forward, left, right, and backwards. When you hit download for this one, we don't need the skin, so download it without the skin. And finally, after you have those 4, we need an idle animation. Again, feel free to pick whatever you want. There is one I know where the character looks like they're holding a rifle. There you go. I guess this one actually, there you go. So this is the one I'm going to use for idle. It's just the character kind of breathing, holding the rifle. And again, make sure we download it without skin. So you can see here in my downloads, I have everything. I have Remy.fbx plus all the animations. Let us start by just importing the character into the game. So we're just going to import the T-pose model. So to do that, first I'm going to make a folder to keep everything organized. And I'm just going to click, drag, let go. We just want to make sure that import static meshes has been checked. We want to make sure import skeletal meshes has been checked, and we want to make sure import materials have been checked. Now, they should all be checked by default, but we just want to make sure those are there so our import comes in correctly. We hit import. It's going to take a bit. And after a while, it's going to just pop up with a whole bunch of stuff, most of it's materials. But we see the skeletal mesh here. If we double click it, there is our skeleton. On the right, we can see all the bones here. We can, click on any of them, and we can see how the bones affect the character by rotating them. And, feel free to, mess around with this. It doesn't really matter. Even if you save this, it is not going to affect the actual character's pose. They will always be T-posed. So if I close it and open it again, they'll be T-posed. So whatever we do here doesn't actually affect the character. It's just for testing. So real quick, this isn't an animation course or even a modeling course, but let's just look at what our skeletal mesh is made out of. It's made out of 2 parts, really. It's made out of a skeleton a skeleton is just these bones. It is just the bones and nothing else. Bones are connected to each other in a hierarchy, and all bones really do is when you rotate one bone in the hierarchy, everything else under it rotates. So you can see spine 1, or spine is the base. It connects to spine 1, spine 2, left shoulder. Basically, it connects to the top half of the body. When I do any rotations on it, it is affecting that, everything under it, all its children. And that's really all the bones themselves are. So you can see the right leg is connected to the rest of the foot. When I move the right leg, it moves the foot. But if I was just to move the knee area, it's not going to affect anything above it. It's just going to affect the stuff below it. Attached to the skeleton is our mesh. We call it a skin mesh. And what skinning in this term means is that every bone's rotation affects certain vertices on the mesh. How much they affect those vertices, how much influence they have, that is part of the skinning process. Again, these all come to us perfectly skinned, perfectly skeleton up for animation. We can see the animations working. We don't have to worry about that. But really what we have to know is just our skeletal mesh is 2 parts. It's bones, and those bones are attached to a mesh via skinning. And that's how we get our skeletal mesh. Finally, we have this little place for animations. So any animations that are associated with this skeleton will show up here. Currently, we don't have anything. We just have this T-pose animation. It's an animation, but it's not really animated. It's just a T-pose. So let's go ahead and bring in our other animations. To start, I just want to make this a little bit more organized so we don't see all these materials here. So I'm just going to make a folder, call it materials. Or heck, let's call it Remy materials. And I will select everything and then deselect whatever is not a material. So skeleton, physics asset, the animation sequence. And everything else is either a material or a texture. Let's just move that there. Just so that we don't have to look at that. Make sure we save everything. And now all I'm going to do is take my other animations. I'm going to select all of them and drag them into Unreal. We can see that, when you initially load this, you would notice that this import is grayed out. It's because we have to make sure to select a skeleton. So if I had the default settings, they would have come in like this, where my import was grayed out. And I would have to click down none and make sure I select the skeleton that these animations go with, which in this case is Remy skeleton. Let's import these things in, and there you go. Everything comes in. Let's make sure to save it. And because we associated these animations with this skeleton, we can see the skeleton right there, like the mesh, sorry. When I click on one of these animations, it's going to open up. And it opens up in that same animation screen that we saw earlier, except now when we look at the bottom right, we see all the animations associated with the skeleton. If I double click on any of them, it plays the animation. Now, let's start off getting these things to work. We have all the little components we need. We actually just have to put them together so that they, make the character that we have animated. We don't want to use the box character anymore. We want to use this character instead. So we'll start off with the easiest part. Let's go into our twin stick. And let's just delete the body, the cube, and the sphere. And let's put our mesh character. Let's put Remy in there. To do that, we don't even have to add a component because the character class already comes with this mesh renderer. This mesh character skeletal mesh component. It's already a part of it. All we need to do is where it says mesh, skeletal mesh asset, we select the asset that we want. They're too big and they're rotated the wrong way, so we just have to adjust that. To start, I'm going to make their feet touch the ground. I know that this capsule is of the half height is 88, which means from ground to up here it's 88 units, which means I have to just move our character down by 88 units. And their feet's touching the floor. That's because they spawned in halfway there. We also need to rotate our character 90 degrees. Nope, just minus 90. So that this arrow represents their forward, because that is a forward in our code, so that should represent it on our character as well. And make them smaller. They're a little too big right now, so it looks like 0.45 is correct. There you go. So if I was to compile this now, go back and let's play our game. Awesome. We have replaced our cube with an actual character. This still looks like a prototypey thing, but you know, it looks way better. Now let's start putting some animations on this. There's going to be two concepts we need to put these animations together. Let's start out with the main one. To get animations really to work in any way using code in Unreal, we have special blueprints for that. We have something called an animation blueprint. It is very similar to the regular blueprinting. It has a lot of the functionality of just a normal actor blueprint, except it's special in the sense that it controls animations at the end of the day. So to make one, we right click, animation, animation blueprint. We select the skeleton we want to apply it to, hit create, and I'm going to call it ABP for animation blueprint, and we will call it twin stick player. So this is the animation blueprint for the twin stick player. Let's open it up, and let's just take a look at this. So real quick on top, we have this thing that's the event graph. This is exactly what we see in the actor blueprint. You know, we have everything here. We have variables, functions, just things that we would tend to see in the actor blueprint. We can see them in the animation blueprint as well. This event blueprint update animation has a delta time very similar to our just event tick, basically kind of the same thing. It's going to run every frame. But the special thing animation blueprints have is this anim graph here. It has an output to it. And this output's always there. We can't delete this. So if you can hear my keyboard, I can't delete it. So whatever we do in this animation blueprint, that's really going to plug into this output pose. That is what we're hoping for. Or that is like our goal. So let's just see that in action. If I was to come back to my content drawer and take one of these animations, for example, we have idle. And I just drag that in here and hit compile. You can see that this is outputting idle into our output pose, and that's what's being played in our character. I can even make this idle loop, and our character looks like they're breathing. In our character, in our twin stick pawn, with the mesh selected, animation mode set to use animation blueprint. That's what this is. It's an animation blueprint. We want to select which blueprint we want to use. And I called mine ABP twin stick shooter. So I'm going to select that. And you can see this outputted animation immediately applies to our character. If I was to play this game now, our character, instead of being in T pose, is in idle pose. Great. So we see kind of how this works. Whatever this output pose is going to be what our character plays. And because we have set this animation blueprint to what is affecting this character, this output pose is going to affect our player character. We don't want it to be just idle. We want it to actually depend. What we want is if our player is moving forward, it plays the forward animation. If they're moving backwards, it plays the backward animation. If they're moving left or right, it plays, you know, the appropriate animation. And if they stop pressing any keys altogether, like they're not moving, it has to play the idle animation. To do that, we are going to use something called a BlendSpace. Let's take a look at that. Real quick, I'm just going to make a new folder and call it animations. And let's throw all the animations in there. Great. Okay. So then in this folder, I am going to go right click, animation, and we want to make a BlendSpace. And I'm just going to call it run blend. I'm not too sure what the naming conventions for blend spaces are, but, you know, just name it something reasonable. Let's just, before we even hop into the blend space, let me just hover over it and let's read the description together. A blend space allows multiple animations to be blended between based on input parameters. So we're going to have some inputs, and those inputs are going to drive our animations. But it's not just going to run them, it's going to blend between them. And that's a key concept of the blend space, is that idea of blending. Okay, so when we open it up, we're greeted with a preview of our character. Most importantly, what we have down here is a graph. Currently, it has two axes named none and none. And these axes go from 0 to 100, 0 to 100. We are going to have these represent. So we're going to have the horizontal axes represent our player moving left and right. So the more right we move, we want to play the right animation. The more left we move, we want to play the left. Same, we want to have the up-down represent our forward and backwards. When we move forward, it goes up in this axis, down in this axis. So in the side, under the asset details, you can see axes settings, horizontal and vertical axis. Currently, their names are none. Let's give them a reasonable name. So I'm going to call this right speed and forward speed. So now these axes represent something more reasonable. This bottom one represents our right speed, so left and right. You know, right would be positive, left would be negative. And same with forward speed. Positive would be forward, negative would be backwards. I'm going to change the minimum and maximum, so it ranges between -1 and 1. We'll see why later. Oops. -1 and 1. So now we can see these axes. They start, both of them start at -1, and the highest they go is up to 1. Which means that the center area is 0, 0. All we need to do to use this blend space, and as we start using it, you'll get a clear idea of exactly what it does, is we start dragging our animations into it. We can click on the nodes, and you can see we can set where the nodes go. You can click and drag them, but really we're just going to set them typing numbers. So we want them to play the idle animation when the character has stopped, which means their forward speed is 0 and their right speed is 0. So that's stock in the center. We want to play their run backwards when they're moving backwards. So their right speed doesn't matter, that's 0, and their forward speed is -1 because that is when they're going backwards. Looks like our idle moved away from 0, 0 for some reason. Next, let's do run forward. So forward again, right speed doesn't matter, it can be 0, but the forward speed is positive now. For left, the forward speed doesn't matter because we're moving left and right. And we're going to move negative on the right axis. That's moving left. And the right is the exact opposite. 0 on the forward speed and 1 on the right speed. So now if I hold control, I can move this little green arrow around. It gives you a little tooltip here that says that. And you can see as I move towards the left, our character plays the left animation. As I move towards the right, they play the right animation. Forward becomes forward, and oh, looks like we have our back and our idle swapped. So yep, that's run backwards, and this is idle. So we want this to be at -1 and this to be at 0, 0. Awesome. Okay, so you can see now when it's at the center, it's idle. If we move backwards, we're moving backwards. If we move forwards, it's forwards. Right's right, and left is left. So that works. We can, to get that idea of what we mean by blending, you can see as I move it forward, we're blending between idle and forward. They're moving forward slowly, slowly. And as we reach the forward node, it stops blending that idle, and it's just playing the forward. So it gives us some semblance of our character speeding up rather than just snapping to this animation. The other cool thing is if our character is moving forward, but then they start moving right as well, you can see that we are blending between forward and right. Our character is moving forward and to the right. And as we go more right, less forward, they're just moving right. So this gives our character very smooth walking controls rather than us just switching between 2 or 3 animations. Our character has very smooth walking controls. They can play anything in between. They don't just play forward or back or left or right. They can play forward left, forward right, back left, back right, and anything in between. That's one of the great benefits is in the blend space is we get to blend between these animations. The other benefit is this is all going to be driven by code. So when we want our player's velocity to affect this animation, and that's how we can do it. So let's start by getting the blend space actually in our animation blueprint, and that's as simple as just going to find the blend space and dragging it in. So you can see there's right speed, forward speed, and there's a output node. We just place that in result. When we compile this, currently right and forward are at 0, 0, so the character's at idle. If I was to make this 1, so they're going to be moving to the right and compile, well, now the character is moving to the right. But we don't want to drive this here. We want to drive this from our player blueprint because our player is the one that knows their velocity, not this blueprint. So we need to get it from there somehow. And to do that, let's start by first affecting these through variables rather than just on their own. So I'm going to make a variable called right speed. Just name it the exact same as what's here. And I'm going to make a variable called forward speed. Again, same as what's here. Let's plug those into each other. Compile it. And in the event graph, if we see there's this thing called try and get pawn owner, so that's convenient because we've attached this animation blueprint to this character. When we try and get pawn owner, it is going to give us our twin stick pawn, which is nice. So we can use stuff from our twin stick pawn. We could cast a twin stick pawn from here, cast to twin stick pawn, but I don't want to do that. I'm going to use the method I showed you guys like in the previous video, which was to use a blueprint interface, because that is a much more modular way of doing this. So it's just a little bit better if we wanted to use this animation blueprint in other characters or in other actors, we can't just cast to each and every one of them. That's going to be a lot of changes to make. Instead, if we use the blueprint interface, it becomes more modular. We just send the message across. So let's first make that blueprint and blueprint interface. I'm going to call it BPI animation. And we just need one function in here. We need a function to get the player's velocity. So I'm going to call it get velocity. And all that needs is an output that is the player's velocity. So we'll make an output called velocity. Velocity. There you go. And we'll make sure its type is vector. Compile it. Go back to our animation blueprint. Class settings. Make sure we implement the interface, BPI animation. And from our try get pawn owner now, let's just call a message to this get velocity function. There you go. And you can see get velocity outputs a velocity vector. We just want to break this vector. And we want to set our write speed to the y-axis and our forward speed to the x-axis. Awesome. So now on every frame, we're going to get velocity. We're going to run this function on our player, which we still need to implement, but we have it set up here. We're going to run this function on our player, and that is going to break, and that is how we're going to set this right and forward speed, and that's going to set the right and forward speed for this blend space. That's going to affect the output of our character. So what we want to do in our pawn is first go into class settings, and let's also implement this interface. So interfaces, BPI, animation, compile that, and under interfaces now, we have a function called get velocity. Okay, actually that gave me some errors. Let's just make sure not to call this get velocity. I think the character blueprint already has a function called get velocity, so I'm just going to call this velocity, and I should be able to compile now. Let me just real quick show you what happens if we do call it get velocity, if it lets me call that again. If I was to come back here and implement this interface, and this is just in case you guys followed along and did this, and now I hit compile, you're going to get some errors here. And the reason is that we already have a get velocity function in the player, and now we have two functions with the same name. That's no good. So first, what we need to do to get rid of this error is to first clear our blueprint interface. Let's not inherit from it. And then we are going to compile again, which is going to give us an error. But you will see now under functions, transformation, there is a get velocity function. Just delete that, compile again, and everything will work fine. What we are going to do is just change get velocity to velocity, or something reasonable that makes sense. I'm just going to make it velocity for this. And now when I implement this interface, it shouldn't give me an error. Okay, awesome. So there was an error just because we used the same name as a function that already exists, which we don't want to do. So now under interfaces, under interfaces, I have this velocity function. There you go. And all I want this function to do is to get the player's velocity. So get velocity, which is already a function here. So that's why we shouldn't call it that. And we just want to pass this velocity along. So let's just see what's happening here real quick. And before we test it, we have this animation blueprint, or we have this blueprint interface that has a function called get velocity. And all that function does is take the player's velocity and output it. In our animation blueprint, on every frame, we are getting our player, we're sending it a message, hey, what's your velocity? It is sending us that back based on this function. And we are just breaking that because we don't care about the Z component. Our game isn't going to have jumping. So we don't care about the Z component, just the X and Y. And we're setting the X to their forward speed because that's what the forward speed represents, is the X axis. And Y goes to the right axis. That goes into our animation graph because these values change. That affects the blend space and moves this pointer thing across so it blends between these animations. So really, if we want to take a look at that, now we can play. We're not moving right now, so our character is in idle. If I move forward, they play forward. If I move backwards, they play backwards. If I move left, it moves left. If I move right, they move right. If I move right and forward, we move right and forward. Back and left, back and left. And that way, just any of these animations blend between each other. And it looks pretty good. If you were using a controller, it would also look fairly smooth. Let's see if our controls just work here. There you go. So you can see with the controller, if I lightly move it, it moves lightly. And if I push it fully, we go faster. So fairly simply, we also got like walking controls implemented because of that. Or like our animations play slower when we move the controller slower. So great, we got our character animated and it looks pretty good. The issue here now is if I'm facing in this direction and I move forwards, it is playing the run forward animation. But really, relative to the direction I'm facing, my character should be walking right. Same thing, when I go downwards, they should be going left, but they're actually, they should be going right, but they're actually going backwards because that is just what we associate it with. And we will address that in the next video. For this one, we just got the animation set up. In the next part, let us address this issue and have the animations be relative to the direction our character is facing as well. But thank you guys for watching.